Good morning. I'm just doing a mic check to make sure everyone can see me, or sorry, hear me and see my screen. You should see a Winter Skywarn spotter training page. I just want to make sure before I get started, y'all can hear and see the presentation. You can let me know if you can hear me by typing in the chat box as well. Okay, perfect. It looks like everyone can hear me and see my screen. So I'm going to give it another minute before we get started. We had over 100 people registered, and there's only about 30 of them in there. Sorry, it was not in the chat. It should be the questions box. So if y'all have any questions throughout the presentation, post them in the questions box, and I'll try to answer as many as I can, but we only have about an hour here of our time. But I'll give more information if your question doesn't get answered, who you can email it to, and we'll get back to you after the presentation. But we'll have some time at the end. So give it another minute here, and then we'll get started. Okay, so I'm sure we'll have a few more people who are trickling in. It is Saturday, so I'm aware people have lots of plans. So I'm very happy for those of you who took time out of your day to come and learn about Winter Skywarn spotter training. I'm very excited to talk to y'all today about this. So let's go ahead and get started. My name is Ashley Rinberg. I am a meteorologist here at the National Weather Service in Greenville, Spartanburg. So welcome to our webinar. If you're having any audio issues, if you can't hear us for any reason, you can also call in for audio. The number is listed there at 866-791-3533, and then the access code is 818-0098. But if you can hear me fine on your computer, you shouldn't need to dial in for your phone, but that's just in case your computer doesn't, the sound's not working for you. If you have a question, make sure to use the questions box to send in your questions. Some of y'all are already doing this. Thank you, Clay. I'm glad he can hear that. I had him making sure he could hear and see my presentation, so that's good to know. Again, I'll try to answer as many questions as possible at the end of the class. I may not be able to get to all of them, but I will try to get to as many as possible. And then here's just kind of what it looks like to navigate this if you're on a Mac or a PC, which I'm sure most of y'all are probably on, or if you're on the web app on your iPad or on your phone, this is kind of what it looks like to help you navigate. Y'all are all muted, and you should stay muted throughout the thing. And then if you have any questions, you remember they just hit the questions box there and type in any questions, and I'll answer those at the end. So if you come across any that you think of during the presentation, go ahead and put them in the questions box, but I won't answer them till later just to keep on time with the presentation. Okay, so let's get started. Now that we've gone through the webinar information, we're going to talk about our course objectives for today. So you're going to want to, you're here because you want to gain a basic understanding of winter weather. Maybe you love winter weather, you want to know more science behind it. We're going to talk about all those things today. You're going to learn how to measure snow, ice, and sleet. We're going to go over all that later in the presentation. And you're going to want to, it's important to know how to report this to us, right? We need to know what's falling where, how much, at what time. So we need y'all out there to become spotters so you can report to us all this information. This helps us with our forecasting. It helps us adjust the forecast if we're seeing a precipitation type we weren't expecting. This helps us a lot, and it helps us know what's falling at the ground, what the road conditions are, things like that. So just some background here at the National Weather Service. Our mission is to provide weather, hydrologic, and climate forecasts and warnings for the United States, its territories, adjacent waters, and ocean areas for the protection of life and property, and the enhancement of the national economy. So where we fall under We fall under the Department of Commerce, and then under NOAA, the National Oceanic Atmospheric Administration. And then we are the National Weather Service. That is where I'm coming from, talking to you from right now. And we are a weather forecast office, WFO. So I'm talking to you from Greenville, Spartanburg, our office here in Greer. So at the National Weather Service, we have roughly about 4,800 employees. We have about 122 forecast offices. We have 13 river forecast centers. We have 9 special centers. Special centers examples are the Storm Prediction Center, the National Hurricane Center, to name a few. And we're responsible for the issuance of timely warnings, forecasts, and array of public services. So here's a picture of our county warning area, or CWA, as we often refer to it in our discussions. We cover 3 states. We cover Western North Carolina, Northwestern South Carolina, and extreme Northeast Georgia. Again, we cover a wide variety of terrain. We have the mountains in Western North Carolina and up in Northern South Carolina and parts of Northeast Georgia as well. And then we have the foothills and the lower elevations east of there. So we have quite a spread of terrain across our forecast area, which can make forecasting very fun, but also complex. So what we do, we don't just forecast, do the 7-day, we do lots of other things. We do forecasts for aviations, we send out TAFs for the airports, GSP, we're on that property. That is, we do those TAFs for the aviation community so they can know whether they can take off or not at the airports. We also do hydrology, which are river forecasts. We work closely with the River Forecasting Center to create hydrographs to let you know if we're expecting extreme flooding, minor flooding, moderate flooding. We do forecasts for fire weather. We actually have an ongoing wildfire in northern Henderson County, so we've been monitoring that today actually. So we do spots for those. We also take observations, whether that's with our sensors, our ASOS sensors at the airports, or whether that's through weather balloons. We also do marine forecasting. We obviously don't do that at our office because we're too far inland, but we do have coastal offices that do marine forecasting. We are constantly monitoring radar and issuing watches and warnings as needed. And most people are familiar with the 7-day forecast. This is on our website. We do that as well. And then we also do something that's called decision support services. So decision support services basically means that we are very in contact a lot with our emergency managers. They can file for us to watch an event. For example, we had a lot of county fairs, state fairs earlier this year. We were watching those and coordinating with the emergency managers if there was any impactful weather going to the fairgrounds. So that is decision support services. I see one quick question in here. I'm going to go ahead and answer that one because it's easy. How many offices in the National Weather Service are there? So we had that one just a slide ago. So I'll go back to that real quick. We have about 122 forecast offices in the Weather Service. Okay, so now that we've talked about what we do, here's some of the tools that we use in the Weather Service. We use advanced computer workstations, and this allows us to view satellite, radar, and computer model data. Here's some winter storm statistics. So winter death statistics related to ice and snow. About 70% of them occur in cars or automobiles. About 25% of people are caught out in the storm. And the majority are males over 40 years old. So that's the death statistics related to winter weather. So related to exposure to cold, about 50% of the people are over 60 years old, over 75% are males, and about 20% actually occur inside the home. So let's break down this chart on the right. This is the weather fatalities from last year. You're probably wondering why I'm talking about winter fatality statistics. Well, it's very important to talk about because as you see on this chart, most of the deaths we see are heat-related deaths almost every year. We see mainly death from heat. Heat is definitely the #1 killer for weather. But if you look to the left under the tornado statistics, you can see the weather fatalities in the red color. We had about 23, and this is across the US, across the Weather Service areas that we service. 23 people died from tornadoes, but if you look at the winter statistic on the right, we had 66 people die from winter-related fatalities. So you can see how winter weather is important to talk about and the safety tips that we're going to talk about later in the presentation. This is why we're doing this. We're just trying to get the message out on how you can prepare to save your life and your property. Okay, so why do we need spotters? Well, we need what's called ground truth. Well, why do we need ground truth? Well, that's because, we have our radar. And the radar beam shoots up a few hundred to several thousand feet up in the air, and the further away you get from the radar, the higher the beam shoots up into the clouds. So in cloud A, you can see it's shooting down at the base of the cloud, but cloud B is further away, and it's looking more up to the middle to higher part of the cloud. So it's actually not seeing the snow that's falling onto the ground. It's not registering that. So this is why we need spotters. You're on the ground, you're at the surface. You can tell us what's actually hitting the surface. So in this case, for example, we know it's snow falling out of the clouds because I added some snowflakes on this graphic, but we need you there to let us know. Are you seeing freezing rain? Are you seeing snow? Are you seeing sleet? So the role of the spotter, you communicate the information you're seeing, the time of the report, what is being reported, what weather is happening, whether it's winter or severe. And we're able to relay that message to our partners to give them information on the ground. That's to our emergency managers, that's to our police departments, our fire departments, and then that allows us to change our messaging maybe on no weather radio or our forecasts to adjust for that need. Okay, so now let's really dive into the science of winter weather. This is why you're all here, right? So we're going to talk about how do winter storms form. We're going to discuss how to measure snow, sleet, and ice in this section, the difference between watches and warnings, as well as what snow, sleet, freezing rain, and black ice are and the different impacts from them. Okay, so quickly, I want to start with the Earth's tilt because it's very important. The reason we have seasons is because of the Earth's tilt. So the Earth is actually closest to the sun during winter and farthest from the sun during the summer. The tilt of the Earth's axis leads to the northern hemisphere being tilted away from the sun during winter and towards the sun during the summer. So because we're tilted towards the sun during the summer, but we're further away, it's actually the tilt, the angle of the Earth towards the sun. So we're getting more direct heating in the northern hemisphere during the summer, whereas in the winter we're tilted away. So we're getting less direct heating or more indirect heating. So that's typically why it's colder in the winter. So here's some fun facts about snow. Snow crystals are translucent. They are not white. The white coloring is caused by sunlight that is scattered off the crystals. Most snowflakes generally fall at a similar speed as the person casually walking through a park. So they're taking their time, falling down, whereas we know rain falls a lot faster because it's heavier. Snowflakes are so light, they kind of just, fall casually. And then fun fact, this is really interesting to think about. All 50 states have recorded snowfall. So every state in the US has recorded snowfall. So what ingredients do you need for winter storm? Well, you definitely need moisture, and our two sources of moisture here come from the Gulf of Mexico as well as the Atlantic. So we can get Gulf moisture, we can get Atlantic moisture as well, so that we have two moisture sources essentially for our area. You also need cold air. I'm sure you're probably like, that's pretty obvious. You need cold air. This can be from an Arctic or Canadian high pressure, but it also could be from something called the polar vortex. And I know we always hear the polar vortex on the news starting around this time of year, more as we get into winter. So let's just talk about the science behind the polar vortex. It's basically a large area of low pressure and cold air surrounding the Earth's north and south poles. The term vortex refers to the counterclockwise flow of air that helps keep the colder air close to the poles. So that's the globe on the left. A picture on the left. Often during the winter in the northern hemisphere where we live, the polar vortex will become less stable and expand, and that basically sends cold Arctic air southward over the United States and has the jet stream on the right, kind of lets it kind of sink southward. So the polar vortex is nothing new. It's thought that the term first appeared in about 1853 from E. Little's Living Age. So the polar vortex is always there. It doesn't just magically appear. It's there year round, but we really see it break out for our area in the northern and southern United States. We'll see it mostly break down in the winter time. And those can send really cold outbreaks down into the US. So winter storm ingredients, the third thing you're going to need is lift. You need some type of lifting mechanism. That could be from a cold front, a warm front, or even low pressure systems. It could be from the mountains, upslope flow. We'll talk a little bit more detail in another slide about northwest flow. We get that a lot here in our area. And temperature differences over water. So lake effect snow, if you've ever heard that term, if you've ever been up to the Great Lakes or heard of lake effect snow, basically what happens is you have cold air moving over a relatively warm body of water. So in this case, the Great Lakes. So that allows the warm, moist air to rise. It condenses into cloud cover, and of course it's cold enough to produce snow, so you can get heavy snow bands that form downwind of the lake. So we hear a lot about this in the wintertime up in the Great Lakes region. So here are the different precipitation types. I'm sure some of these you're very familiar with. We have something called graupel. We have sleet, snow, and freezing rain. I'm sure y'all are more familiar with sleet, snow, and freezing rain than graupel, but I got a lot of questions last year when I did this on graupel, so I wanted to break down what that is as well. So graupel are soft, small pellets formed when supercooled droplets, so that's a temperature below freezing, so below 32 degrees Fahrenheit, freeze onto a snow crystal. And this process is called riming. Graupel is also called snow pellets or soft hail sometimes, as the graupel particles are particularly fragile and generally disintegrate when handled. So like, you know, when you hold a hailstone, they're usually pretty hard, and depending on the size, they might take a while to melt. Whereas graupel are very soft. You can squish it with your hands and it'll melt pretty quickly. So that's the difference between graupel and hail. Get a lot of questions on this, so I wanted to put it in the presentation. Next, we're going to talk about sleet, which are small ice particles that form from the refreezing of partially melted snow crystals or liquid water droplets. Sleet occurs when snow crystals fall into a warm layer of air aloft, and they partially or completely melt sometimes, and then they refreeze as they fall into a layer of air that is sufficiently below freezing before they reach the ground. Sleet is also sometimes referred to as ice pellets. And snow, I'm sure all of y'all's favorite. Snow forms mainly when a super cold water droplet freezes and then grows through the process of diffusion of water vapor onto the surface of the ice crystal. And this basically happens without it going through the liquid stage. So snowflakes that most of us are used to seeing are actually not individual crystals, but are actually aggregates. And aggregates are collections, so they collect onto one another, of snow crystals that stick together or otherwise attach to each other. And aggregates can grow to very large sizes compared to individual snow crystals. So if you were to take a snow crystal or some snow from your yard and put it under a microscope, you wouldn't just see individual flakes. You're going to see those aggregates because they all link together. Freezing rain. This is my least favorite type. I'm not going to lie to you. It is awful because it causes the power to go out. It causes the roads to be undrivable and uninhabitable. It's not fun. So freezing rain forms when liquid drops fall through a very thin layer of sub-freezing air at the surface. So the surface, the ground, any surfaces, power lines, trees, cars, for example, are below freezing. And they don't have time to freeze into ice pellets. So it's raining outside, right? And most of the air is above freezing, but right at the ground where we are, or in those elevated surfaces like bridges, power lines, trees, those surfaces are below freezing, below 32 degrees Fahrenheit. So even though it's cold, that water doesn't have enough time to freeze until it comes onto contact with the freezing surface, and then it freezes immediately on contact. So the drops reach the ground as liquid and freeze on contact with surfaces that are usually below freezing, and it creates a coat of ice wherever they land. So look at these tree branches, you have a coating of ice there. So how do we get these different precipitation types? I kind of talked to you through it verbally, so I want to show it graphically. I'm going to show another slide after this as well. I'm a very visual person. I think it's important for us to have visual cues, right? I talk to you all day long about the processes and read it off, but you have to see the pictures to really get it to click, right? Well, I'm sure most of you, or some of you might not know this, but all precipitation actually starts out as snow. So even when it's raining in the middle of August and it's like 90 degrees out and we have a thunderstorm, those raindrops were once snow crystals, snowflakes. So what happens is all precipitation starts as snow. So we're going to start on the left side of the graphic on the snow side where the little snowman is. So basically what happens is you have all of your precipitation, what starts out as snow, and all of the blue on this graphic is going to represent air that's below freezing. All of the red on this graphic is going to represent warm air or air that's above freezing. So in this case, we don't have any red back here, it's all blue. So it's all below freezing, all the way from the base of the cloud, all the way down to the surface or the ground where we live. So it falls as snow. Well, when we get sleet, it starts out as snow, but we have a very thin layer of warm air aloft. Often this is referred to as a warm nose. And you can kind of see in this picture, it looks like a nose is sticking out with a column of air. So these snowflakes fall into this warm layer, and most of them, and some of them will either partially melt or fully melt. And then it falls into a layer of cold air once it keeps falling near the surface and just above the ground, and it has plenty of time to freeze because we have a pretty decent column of cold air, so that freezes into sleet. Now for freezing rain, like we talked about, remember it starts out as snow, but look at how much deeper the warm air column is. It basically allows all of the snowflakes to melt into rain, but just before it hits the ground, we have the air temperature that's below freezing, but the raindrops just do not have time to freeze before hitting the surface, so they're still falling as rain, but as soon as it comes into contact with any freezing surface, it turns into freezing rain, and it just freezes on contact with cars, power lines, and sidewalks, bridges, things like that. And then when we get rain, we again start out as snow, but as you notice, it melts completely all the way down to the ground and falls as rain because we have above freezing temperatures through most of the column. So I'm going to show kind of a different way of viewing this. This is called sounding data. When we release a weather balloon, this is kind of what the data looks like when we get it back on our computers. So we often refer to these as vertical profiles. So this is in Celsius. So this is the 0 degree line you see there in blue. That is 0 degrees Celsius. That is 32 degrees Fahrenheit. So that is at freezing or below freezing. So the red line is going to be the temperature curve, and the blue line is going to be the dew point curve. The dew point is just the measure of how much moisture is in the atmosphere. So when the temperature and dew point are closer together, it shows us there's plenty of moisture. And we talked about we need moisture in order to have winter weather, right? We also need some sort of lift, and we need cold air. So we have all three of those in the sounding here. So as you can see, both the temperature and the dew point lines are below freezing through pretty much the whole column. They might be at freezing closer to the surface where we live, but this would be a snow sounding because everything is below that 0 degrees Celsius line. Everything is below freezing. Here's an example of sleet. So now when we say the warm nose, this is what I'm talking about. So I highlighted it here in yellow. This is what we consider a warm nose because it looks like a nose sticking out, right? So here's the temperature and the dew point curve. You can see it's kind of going past the 0 degrees Celsius line, and it's going into above freezing. So we have this pocket of warm air that this precipitation is falling into. So this basically allows the snow to melt or partially melt. But then, as you notice when we go further back down, we see temperatures are well below freezing at the surface, so really, really cold. So that gives it enough time as it's falling closer to the ground to refreeze into sleet pellets. And then freezing rain, this is what a freezing rain sounding looks like. So here's the warm nose. Notice how much bigger it is than the sleet warm nose. It's often a really big warm nose. And that just means that it has time to completely melt. But as you can see, it's below freezing at the surface, but it's such a sharp temperature drop that it just doesn't have time to refreeze. So it freezes on contact with those elevated surfaces. So that is how you get the different precipitation types. And of course, rain would just be the whole profile. About 700 millibars or below would be above freezing. So it would fall as rain because it's above the 0 degrees Celsius line. Okay, so rime ice is often formed through the freezing of supercooled water droplets on an object that has a surface temperature at or below 32 degrees Fahrenheit. So it usually forms in dense freezing fog situations. So I just wanted to talk about some other types of winter weather that we don't often get all the time, but they do occur. So you can tell this is up at a higher elevation. There's probably freezing fog occurring, and this is what rime ice would look like. We also have something called hoarfrost. This is actually a picture from Waynesville, North Carolina, from Bob Child. Credit him there. And this is up in, the lower elevations of the mountains. So hoarfrost is formed through the deposition of water vapor onto an object that has a temperature at or below 32 degrees Fahrenheit. And deposition is the change of state from a gas to a solid. So it goes straight from a gas to a solid. That is what deposition is. And it usually occurs on cold and clear nights with calm winds. So kind of think of it like, you know, fog develops. We need cold, clear nights, calm winds. So that's what allows hoarfrost to develop when we have enough moisture, the temperatures below freezing, we have clear skies, calm winds, and it's very cold. So I want to talk about the different types of low pressure systems that we can get and the different types of weather they can cause. There's one called a Miller type A low pressure system. So the Miller type just refers to the track a low pressure system takes up the East Coast. So a Miller type A storm has one coastal low that travels across the Gulf Coast and then moves up the East Coast while gradually strengthening. Here's some characteristics of a Miller type A storm. Precipitation is usually either rain or snow. There's very little mixed precipitation, so there's very little sleet, there's very little freezing rain. And there's a very narrow transition zone between rain and snow. So you could be very, very close to getting snow, but it could be a very sharp transition where you might just be on the other side of the low where it's warmer. So you're getting rain while maybe someone 10 miles south or east of you or north of you could be getting snow depending on how it's set up with the temperature trend. And then we also have a Miller type B low pressure system. And it's usually a storm that consists of two distinct lows. One is usually inland and approaching the southern Appalachians, and one is usually coastal. The inland low usually dissipates though as the coastal low strengthens. So in this case, we have two lows. And the characteristics of a Miller type B storm is that various precipitation types are possible across the region at any one location, including multiple transitions between precipitation types. So this is messy. You could have snow, you could have a transition to sleet, and then you could have a transition to freezing rain. You could have that going off and on throughout the event. It's just very finicky. So the wintry mix of all types would be possible in this case. And these are basically examples of what we call nor'easters. I'm sure y'all are more familiar with this term called winter's fury. You know, these usually pack quite a punch. And as you can see, they typically track up the East Coast from Florida up to Maine. And snow will basically fall typically to the west side of the low pressure track. And the areas highlighted in yellow here are the areas that are most notorious for seeing nor'easters develop and dumping a lot of snow. So it's just northeast of us, but that doesn't mean that we can't see impacts from these. So just keep in mind though that small variations in the track could lead to big differences in snow totals for different cities. So if it shifts further west or further east, that would have different impacts on the snow totals. Okay, so for our area though, what we get most often is called northwest flow snow or upslope snow. So when the wind blows against the mountains or hills, it is forced to rise. This is basically a term that's called orographic lift. And then as the warm, moist air rises and cools, water vapor condenses, resulting in clouds and precipitation. And this results in the windward sides of the mountains and hills receiving more snow than the surrounding areas in winter. So this typically for us occurs along the North Carolina and Tennessee border. And when we have northwest winds, hence northwest flow, northwest winds lifting moisture up the western side of the mountains. And this is often a result of some type of upper level forcing. This could be behind a departing cold front. It could be wraparound moisture from a departing low pressure system. And a fun fact for northwest flow snow is sometimes the origins of the moisture source can come all the way from the Great Lakes region. So sometimes we have a really good Great Lakes connection. And often when you can track that moisture back from the Great Lakes, that's typically when we have our most impactful northwest flow snow events. So here's an average annual snow map for our area for Greenville-Spartanburg. This is for the new climatological average. So this is from 1991 to 2020. It's about a 30-year average. So as you can see, and as you would suspect, most of the snow occurs in the mountains because you have higher elevations. They're typically colder in the winter because they're up higher in the atmosphere. And you typically have a lot lower totals east of the mountains just because we're further away from the colder air. We're at lower elevations. So we pretty much get anywhere from about 2 to 4 inches outside the mountains, and anywhere from like 5 to 10 inches across the mountain valleys. But as you can see, like Mount Mitchell in Avery County, and Avery County there, they win with the snowfall totals. That's about 89.1, I believe, at Mount Mitchell. So we have some pretty snowy elevations, but typically that's going to be for the higher elevations. They're going to see the most snow just, again, because they're up higher in the atmosphere where the colder air is. So let's talk about snow ratio. I know this can be kind of confusing, but I want to break it down because it is important. So snow ratio is the percentage of water within a sample of snow. And an old rule of thumb was that for every 10 inches of snow, there'd be 1 inch of water. So let's say it snows 10 inches here. By the time that melts, that'd basically be equivalent to 1 inch of water. So there are different variables that affect snow ratio: the depth of the warm layer from the surface, so the warm nose like we were talking about, the amount of ice in the snow producing cloud. If it's windy, that can help fracture the snowflakes and reduce the snow ratio. And deep cold often leads to higher snow ratios. So an SLR is a snow ratio, so I just abbreviated it here. So an average SLR for the North Carolina mountains is roughly a 10-to-1 ratio. So 10 inches of snow for 1 inch of water, but it tails off climatologically to an 8-to-1 ratio. So 8 inches of snow to 1 inch of water over the lower Piedmont and Charlotte metro area. So the lower the ratio, the more wet the snow is. A lower ratio has higher water content and gives you less snow accumulation for the given liquid equivalent. So low ratios are typically when temperatures in the column are at or above freezing. The higher the ratio, the more dry and fluffy the snow is. A higher ratio has lower water content and gives you more snow accumulation for the given liquid equivalent. High ratios are typically when temperatures in the column are well below freezing. So typically here we see more wet snow in the south, southeast, but once you go further north or out northwest, you typically have higher ratios, more drier and fluffier snow. So for measuring snow and sleet, this is very important. Now the supplies is on here, it has pictured like a flag and a snowboard. This is optional. You don't have to have a snowboard. But if you do have one, since we recommend to get a flag to post where it is near where you put it in your yard, so that way you know where it is because it's white, right? And the reason it's white is because it reflects more sunlight, so it helps the snow not melt as quickly. So that's why the board is white. And it can be hard to find if you have it out in your yard when we have snow. So that's why you have the little flag. But most often or not, you're just going to need to get a ruler. If you just have a ruler, that's fine. If you have a snowboard, that's great. So first, in order to figure out where you want to measure snow or put your snowboard before an event happens, right? You want to find an open area away from tall objects, but it has to be sheltered from the wind because the wind could push snow off the snowboard. It could artificially inflate or lower the totals depending on how the wind is blowing. And then next, you want to set up before the snow begins. So if you have a board, put your board out with the flag in it in the part of your yard that's sheltered from the wind but open area. And then next, you're going to measure the snow. So you record the total to the nearest 1/10 of an inch. And then after you're done measuring, you wipe off the board. So you measure once daily at the same time. And then after measuring, you place the snowboard back on top of the snow and then wipe the snow off. Or if you don't have a snowboard, you just go out and measure with your ruler. So when the snow stops, you want to measure as soon as possible because as soon as the sun comes out and the snow starts to stop falling, it can melt very quickly. So you could get lower totals if you wait later in the day to measure. And then after you're done with that, measuring the snow, you send us your reports via our spotter phone, which I'll give you the link to that later, on Facebook, Twitter, social media. And you can also fill out a form online or use something called MPing, and I'll talk about what MPing is here in a minute. I have this linked on here for more information on exactly how you can measure snow and sleet. Our Opal Chris and one of our forecasters, Clay Cheney, actually went out and did a demonstration for this. And obviously this link is very long, but I just want to put it in here to let you know it's available. But you can also Google NWS GSP measuring snow and ice on Facebook, and the video should be the first link that populates. But I also want to point out, because I forgot to mention this, there's a tab called handouts, and I have attached 3 handouts to this webinar. So you're able to download those onto your computer. And I have one that's called Winter Weather Spotter Talk links. And I have every link that I mentioned, phone number, anything like that, linked on this PDF. So you can easily go click on it and open it to view this video I'm talking about. But this will go in way more detail than I have time for today to talk about how to measure sleet and snow. So you can download those handouts there at any time. So let's talk about freezing rain. So what is freezing rain? Well, we talked about the profiles, right? We see what we need to have freezing rain. It freezes on contact with cold surfaces as it enters a shallow layer of temperatures at or below freezing. And this can create dangerous coating of ice on roads, walkways, trees, and power lines. So ice accumulation increases the weight of a span of power lines by up to 500 pounds. Patches of ice on roads and highways make traveling extremely dangerous, especially black ice, because you really can't tell it's there. It looks like water. And then ice accumulation increases the weight of a tree branch by 30 times. So this is why we say the power could go out, because you have the ice accumulating on the power lines, or the weight of the trees near the power lines becomes too much that branches or the whole tree starts to sag or fall onto the power lines. So once you start getting heavy accumulations of ice, it can bring down trees and power lines, and this can disrupt communications and power for days, while utility companies have to wait for the storm to be over to repair the damage, to redo the power lines, to pick up the tree damage. And even small accumulations of ice can be extremely dangerous to motorists and pedestrians. Bridges and overpasses in particular are really dangerous because they freeze before other surfaces. So why do they freeze first? Well, there's no ground underneath the bridge, which means the entire structure is surrounded by cold air. So you have cold air flowing over the bridge and you have cold air flowing below the bridge. And freezing isn't uniform. So if the bridge has shady spots, those can be icy, whereas parts of the bridge that maybe see more sunshine that aren't shady, it'll be melted, the ice will be melted. So you could be hitting, you got to just slow down when you approach bridges, because if there are shady spots, you're going to have patches of ice that haven't melted throughout the day, even if it's above freezing. So you just want to be really careful. So just slow down when you approach a bridge. Usually, often you see the bridges freeze first. That's your warning to maybe slow down if you're driving out in winter weather, especially during freezing rain event or sleet event, and even snow. It could just be slick. So freezing drizzle is another type of event we could get, and you think, oh, drizzle, like how does that really impact anything? Well, it could be as disruptive as freezing rain at times, because a freezing drizzle is a fine layer of ice that forms, and it can be kind of hard to notice on the road, and it can be very dangerous because it can kind of catch you off guard. So safety tips, if you ever encounter freezing drizzle, if you're noticing it's drizzling outside and it's freezing to your windshield, or it kind of sounds like little tiny pellets are hitting your car, that could be freezing drizzle. So slow down. Do not use cruise control ever when you're driving in winter weather. That's like the worst thing you can do. And always leave plenty of distance between you and other vehicles. So this is what we would call kind of a sneaky winter weather hazard. Ice storm warnings. These are usually issued for ice accumulation of a 1/4 inch or more, because studies have shown that a 1/4 inch of ice accumulation onto branches, power lines can be enough to cause significant damage. So the amount of ice accumulation will make travel dangerous or impossible, and likely lead to snap power lines and falling tree branches, and travel is usually strongly discouraged during an ice storm warning because it's just very hard to navigate the roads. So how do you measure ice? We talked about measuring snow and sleet a little bit. Again, you're going to run around on measurements to the nearest 1/10 of an inch. So you have 2 ways you can do this. Depends on how much math you like to do, basically. So method number 1 is you find a flat surface and measure ice accumulation with a ruler, as you can see here. So there's a flat surface. Or you can take an icy branch and measure the amount of ice accretion on each side. And then you do that with a ruler. So then you're going to take the average of the 2 measurements. So in this picture, we have ice on the left side of the branch and the right side. So we're going to ignore the branch itself, because that's going to inflate the average. So you're just going to measure the ice that's added onto the branch. So you'll measure the right side, the left side, add them together, and then divide by 2, and then that will give you your ice accumulation. Or if you just really don't feel like doing math, you could go find a flat surface and measure the ice that way with your ruler. That's usually the easiest way to do it. Okay, freezing fog. So freezing fog happens when tiny super cold liquid water droplets and fog freeze instantly on exposed surfaces when the temperatures are at or below freezing. So this is a good example of freezing fog on this tree here. It kind of looks similar to the hoarfrost a little bit, or the rime ice we saw. They can be kind of hard to differentiate a little bit because they kind of look similar. So surfaces on these droplets may freeze on include tree branches, stairs, rails on the stairways, sidewalks, roads, and vehicles. So you want to use extreme caution if you have to travel, because it can be as tricky as freezing rain or freezing drizzle. It can be very slippery. And it can also cause black ice to form on roadways. So what is black ice? Well, this is another one of those sneaky winter hazards. It can form on any road, but also along curbs and drainage areas due to melting snow. It's more prevalent at night because that's typically in the winter when we're going to see, temperatures drop below freezing, but can still be lingering around in the morning hours, especially in the shady spots. So don't drive during freezing temperatures after a rain event or snow melt. So say, for example, we had a lot of rain come through with a cold front and we're expecting temperatures to drop very quickly behind it. Well, if that rain fell and those temperatures are dropping quickly below freezing, we don't have enough time for that water to evaporate off the road, so we can get black ice that way. Or we have a snow event and the sun comes out, and even though it might still be above freezing for a little bit, the sun and the above freezing temperatures help melt the snow. But then once the sun goes down and if we expect below freezing temperatures, it's going to allow all of that moisture that melted from the snow to refreeze onto the roads. Okay, so wind chill. So here's the science behind why we experience wind chill, why wind chill is important. So when we have no wind, this example on the left is with no wind. Your average body temperature for the human body is about 98.6 degrees. So when people lose heat through convection, so in this example, this is convection, losing heat to your surroundings, there's still a thin layer of heat between our skin and our cold surroundings. So when there's not any wind, we're able to kind of maintain our body heat better. But when you factor in wind, heat is moved away from our bodies. So it's like basically being pushed off of us. So in this example, she's been outside for a while, she's bundled up, and her body temperature is now dropped to 95 degrees because when it's windy, the moving air breaks up this insulated layer we have. It speeds up heat loss by whisking away the warmth from our skin. And hypothermia can begin when our body temperature drops 2 or 4 degrees. It doesn't take very much. So whenever we issue wind chill products, you want to take this seriously. And here's an example of a wind chill chart. Basically, the colder and the windier it is, the more severe your wind chill is going to be. So on the left side here, we have wind plotted, so from 5 miles per hour to 60 miles per hour, and then we have temperature plotted from 40 degrees to negative 45. Never experienced a negative 45 degree temperature. I don't think I ever want to. That sounds pretty interesting, but you want to go real extreme here. If you have a negative 45 degree temperature and a 60 mile per hour wind, your wind chill is going to be negative 98. I mean, that's crazy, right? But typically here, we're looking at maybe wind chills in the teens, the single digits, So typically, like, let's say if we're up high, like at Mount Mitchell, for example, we've got like a 45 mile per hour wind gust and it's 10 degrees. Well, that's going to lead to a feel-like temperature or wind chill of negative 16. That's fairly frequent up there, depending on how windy it is and how cold it is. So that's kind of an example of how we calculate and factor in wind chill and kind of how it does, how that removes the heat from your body. So there's the actual equation at the bottom. If you're super into math there, I'm not really going to get all into that as we don't have time, but that's how it's being calculated and that's where these numbers are coming from. So a wind chill watch versus a wind chill warning. Wind chill watch means a wind chill watch is issued when we have very cold air and the windy conditions are possible. When a wind chill warning is issued, that means we have very cold air and windy conditions are expected. So when you're in a watch, you just kind of want to be prepared. It's going to be, cold and windy the next day. But when we have the warning out, you can basically expect the potential for maybe the conditions to lead to frostbite or hypothermia. So you want to limit your time outside, dress in layers, and cover up any exposed skin. So warning signs of hypothermia, it's usually confusion, shivering, difficulty speaking, sleepiness, and stiff muscles. So cold weather can cause hypothermia, so dress in layers and cover your exposed skin and definitely limit time outside, especially if you're expecting very intense wind chills. So I get a lot of questions on what is the difference between a watch, a warning, and advisory. Advisory comes out a lot when we have winter products out. So a warning means take action. We're expecting this to happen. It's meeting warning criteria. A watch means be prepared. We have about a 50% chance of seeing, or 50% confidence level of seeing warning criteria take place. And an advisory kind of means exercise caution. So a winter weather advisory means that wintry weather is expected, and it could be moderate or light amounts of snow. So basically, it could be snow, sleet, or freezing rain, excuse me. And it can cause, you know, some slick travel areas. But a winter weather advisory, basically means it doesn't meet warning criteria. So it's basically falling below warning criteria. So it's still impactful, but it's not meeting our local warning criteria. When you have a winter storm warning, that means that we are meeting warning criteria. So whatever that criteria is for the mountains versus the Northeast Georgia versus outside of the mountains, it's different for different locations, because some locations are used to getting a lot of snow, some are not. So we have lower totals outside the mountains for warnings and higher totals across the mountains when we issue warnings for there. So take action when there's a winter storm warning, because we're expecting it to happen pretty soon. When there's a watch, you just want to be prepared, make sure you have all your stuff ready, and have your preparations being done. So here's another way of viewing it. Winter storm watch, you're kind of like, yeah, okay, I'm watching the news, I'm looking at the Weather Service website, I'm listening to NOAA radio, I'm gonna find out what's possible, right? Winter weather advisory, you're kind of like, man, you know, we didn't get as much as we were expecting, or we transition to an advisory after a watch because it doesn't meet warning criteria. And then when you have a winter storm warning, you're like, oh my goodness, we're gonna get snow, we're gonna get ice or sleet, freezing rain, whatever it is. So you're prepared, right? So that kind of shows the emotions of the different watch, warning, and advisory. So here's another way of thinking of it. A watch is like you have all your ingredients together. So if you've ever baked a cake, cookies, scones, whatever you like to bake, cupcakes, you know you have to get all your ingredients out, right? They're all sitting on the counter. You got your butter, your eggs, your flour, your sugar, your vanilla, whatever it is, chocolate chips, and it's all sitting there, right? So when we're forecasting, we're seeing the potential for these ingredients that may or may not come together. So when we issue a watch, that means those ingredients are there, but we're watching to see if they come together, right? So if we're not as confident, we might go to an advisory, but if we're more confident, we might go to a warning. And again, that depends on how much we're expecting to fall, how much snow, sleet, freezing rain. So if we transition to a winter storm warning, that means all of the ingredients came together and we're getting snow, sleet, or ice. We're getting warning totals, right? So think of it like that. A watch means you're gonna bake a cake, you have all your ingredients together, but they haven't come together yet. A warning means they've come together and you've gotten cookies, cake, cupcakes, scones, whatever it was that you're baking out of it. So some things to keep in mind with winter weather forecasting is that snow and ice totals can vary greatly over short distances. A heavy band of snow may form, dropping more snow in one location while significantly less snow falls just a few miles away. Winter forecasts can change pretty frequently, and forecasts may change as new model data becomes available. So we always encourage people to have multiple sources to look at. Always check weather.gov/GSP, that's our website, for the latest information. Read our forecast discussion, look at our 7-day, go back and check it every day, because things change. One little change, one little ripple in the atmosphere can have big downstream effects. So focus more on the impacts. Don't focus too much on exact accumulations. Don't focus on, oh, we're gonna get 6 inches of snow. Don't focus on, oh, we're gonna get a 1/4 inch of freezing rain. Focus more on what that could potentially do. Is it gonna knock my power out? What should I have prepared? Do I need to shovel my driveway before I go to work in the morning? Things like that. Consider the full range of possibilities. Know your winter weather terminology. So we talked about a watch versus warning versus advisory. If a watch is issued, get prepared for hazardous weather. If a warning or an advisory is issued, take action, as hazardous weather is occurring or will occur soon. Rely on multiple dependable sources for weather information. This could be your favorite broadcast meteorologist. This could be NOAA Weather Radio. This could be social media, but find reliable sources, because not all sources are reliable. You can also talk to your family, friends, and coworkers. Wireless emergency alerts as well, WEA. That's more for severe stuff, severe like tornadoes, but still helpful. And radio as well. So choose your information sources wisely and follow a name or organization you know and trust. So let's just talk about a few winter safety tips here. So when you're in ice and snow, take it slow. That's easy to remember, right? Each year, there are over 1,000 deaths and 100,000 injuries due to vehicle crashes during winter weather. Now, obviously, we don't deal with that as much out here, but when it snows, we know everything shuts down because we're just not used to driving in the snow. So if we do get snow or ice, make sure to clean your vehicle off before driving because flying snow from cars can cause accidents. All that snow you didn't shovel off in the top of your car, as you're driving faster, that wind's going to blow it off and it's going to blow into someone else's car and they're not going to be able to see and they may have a wreck or cause a chain reaction to have multiple wrecks. So keep it slow. Do not use cruise control because the roads can be slick even if they just look wet. Just don't use cruise control ever during winter weather. It's just better to have your control outside of that. Leave extra distance between you and vehicles. This is kind of always a good example for any type of weather. Just give yourself enough room. And obviously you want to stay far away from snow plows because as they're plowing the roads, that could impact you. So another good thing to have is an emergency supply kit for your car. And you can get this prepared pretty much any time of year and just leave it in your trunk or your back seat, whatever. We recommend, here's some of the things we recommend. I mean, obviously you want to fill your car up before winter weather is expected because if you get stranded, you want to make sure you have a full tank of gas and can, survive off that till you get rescued. Bag of sand or cat litter to help you get out of ruts you might have gotten stuck in like snow or ice. Blankets, boots, mittens, warm clothes, flashlights, ice scraper, snow duster to get stuff off your car. Water and snacks in case you do get stranded. First aid kit's always good to have no matter what. Cell phone charger, jumper cables in case you have to jump your car. Road flares in case it's like a blizzard out there. We don't get that very often here. It's possible, but we don't really get that often here. But that way people can see that you're there and they won't, run into you. So other tips, make sure you pack your emergency supply kit like we talked about, winterize your vehicle. Check updates before you get on the road. Check the road conditions. Check the National Weather Service forecast. If we have an ice storm or a winter storm that is strong enough to knock out the power, here's tips on how to stay warm. You want to close blinds or curtains to keep the heat in. You don't want to open them because the more you have sheltered, you think, oh, well, the sun will warm it up. Not necessarily. You have a lot of snow, it's usually really cloudy. You want to close those blinds and curtains to trap the heat in your house. You want to close off rooms to avoid wasting heat. So sit out in your bedroom or family room and close the doors to the rest of the house so the heat can kind of stay centered in the house. Wear layers of loose fitting, lightweight, warm clothing. Eat and drink plenty of food and water. Make sure to have water on hand and non-perishable food in case the power goes out. And then stuff towels or rags in the cracks under the doors, whether that's the doors leading to outside or your bedroom doors. That's just going to help hold the heat in and insulate it, especially if you lose power. Then again, don't forget about your pets. Bring them indoors. They get cold too. Make sure they have a dry and warm place to stay with plenty of food and water. And then generator safety. This is very important. This applies for hurricane season as well, which we are still in, by the way. It does not end until the end of this month. Generators can be dangerous if not used properly. You always use them outside. Do not put them in your house. Make sure the generator is in a well-ventilated area because if it's in the house or if it's not well ventilated or it's too close to the house, you could get carbon monoxide poisoning and it can kill you. It's the silent killer. You don't even realize it's kind of happening. And it's always a great idea to have a carbon monoxide detector as well. Have those in your house. That way it'll alert you if the levels are getting too high and unsafe. So in summary, what do you report to us? Well, you need to report snow and sleet accumulations and ice accumulations. Let us know if there's any down trees or power lines. This is important for us to know. We can do a local storm report on this, as well as road conditions. That way we can relay that to our emergency managers as well as our emergency services. So when you call, here's what we need to know overall. We need to know who you are, what you have seen, where the event is occurring, and when it happened. So give us the time of the report, how much has fallen, what is falling, and who you are and where you live. So I talked about MPing earlier. This is another app you can download and it'll send your reports directly into our database in our computers. And MPing just stands for Meteorological Phenomena Identification Near the Ground. So that's MPing. So you can send us your weather reports via MPing. So you download this app on your smartphone and you can go to mping.nssl.noaa.gov. And I believe I have this linked in that handout I have on here. So if you can't write that down quick enough, it's in the handout. So also you can submit your reports to social media. You can tag us on social media on Facebook and Twitter. Follow us as well. You can comment on all of our posts. Let us know what you're seeing in your area. We love to see your pictures as well. And I saw there was a question about CoCoRaHS and data. We do ingest CoCoRaHS data into our system. So CoCoRaHS is a community collaborative rain, hail, and snow network. You can actually sign up to be a CoCoRaHS observer. Again, this link is listed in the handouts that I have attached. So you can sign up and let us know how much rain you got, how much snow you got, how much ice you got. You can apply and pay for the things you would need, like a rain gauge, a snowboard. You can buy those things and you can use those to report to us. It's very helpful. So how do you contact us? Again, all this information is on the handout page. If you can't write it down or just take a picture with your phone, you can call our winter weather hotline at 1-800-267-8101. You can also call our forecast office. This hotline will direct you to our forecast office. And we're open 24 hours a day, 7 days a week, so we will get your report. And if you want to report winter weather, you can go to weather.gov/GSP/reporting. You can also register to become a spotter. I highly recommend that. If you're not already a spotter, go ahead and register. Again, all of this stuff is linked on the handouts I sent. So, and if you have any questions, just feel free to email us at our spotter email, gsp.spotter@noaa.gov. Now, I do want to mention, because I get a lot of questions on this and lots of emails after I do these. One, we do not issue spotter numbers anymore. You will not get a spotter number. This spotter registration, since you've completed a spotter talk, you're good to go. You can go ahead and register. We are also doing a few severe talks as well that are upcoming later this month. If you are interested in severe, go on our website, check out those times. We also have been posting them to our social media, so you can register there. But if you're already a spotter and you're registered, you've done the severe training, you don't need to re-register for this because there's not really a winter weather specific. It's just a spotter. You help us with all kinds of weather. So again, we don't give out spotter numbers. And if you've already done the spotter registration, but you just wanted to learn more about winter weather, you don't need to re-register. So just FYI on that. So looks like we have some time for some questions. Let's see, we have about 5 minutes. So let me see if I can answer some of these real quickly. And again, I'm going to leave this screen up so y'all can write this information down. But if I don't get to your question or you think of something else later, just email us at that email address at the bottom there. So which office augments the ASOSs I talked about? I believe that's going to be both coordination between us and the FAA. Let's see. Is it possible for a tornado to get a tornado in the winter? It is. If we have the conditions, sometimes, you know, it can get, sometimes we have a secondary severe weather season that can start like in November to December. And that's when we just have, you know, warmer temperatures. If we have a strong front that's coming through and it's well above freezing and we have instability, we can get severe weather that develops. That's fairly often. Severe weather is possible year round, kind of unlike winter weather. Winter weather is really dependent on cold temperatures, right? So it's not as often that we would see winter weather outside of winter or the spring or fall. And I did answer that one. We do take snow reports from CoCoRaHS, so there's that answer there. And then what is an outlook? So an outlook basically just means like you're looking out. So we have certain things like the Climate Prediction Center does outlooks. The Storm Prediction Center does outlooks. So the Storm Prediction Center is probably the most famous one that y'all probably know. It's severe weather outlook. So it kind of gives what if we're expecting any severe weather. So it gives an outlook for the next couple days. So days 1 through 5, I believe. So they may issue severe potential on day 1, day 2, or day 3. So that's what an outlook is. Which of the 3 handouts has those web addresses? So let's break that down really quickly. So I have 3 handouts. You're going to want to do the one called Winter Weather Spotter Talk links. That one will have the links to everything. There's also a carbon monoxide handout and tells you about the dangers of carbon monoxide, and a winter prep checklist. So if you want to print that off so you can make sure you're ready to go before a watch or warning is issued, or just, you know, to know what you need to do to prepare. So that's going to be that one. If we are in the Wakefield, Virginia district versus the Greenville, Spartanburg, do we use the same contact information? So you're going to want to go to Wakefield's area. So that's actually, Wakefield is the National Weather Service in Wakefield there. It's actually in Wakefield. So go to their website and you can just Google NWS Wakefield, Virginia, and they should have a spotter contact information for them, because this is going to be for us locally here at Greenville, Spartanburg. So let's say you're wanting to send in your measurement to Wakefield, but you use this contact information I have up here, that's going to come to us. Now we'll obviously relay that to the other office, but you want to mostly send your reports to your local office. Okay, I think I've gotten most of the questions that I can answer. If I hadn't answered your question, send me an email, because I might need to look up some information about it. But I hope y'all all enjoyed the presentation today. And again, if you have any questions, just email us at gsp.spotter@noaa.gov. This is being recorded, so you will get a recording of this in about an hour. So probably around 1:15, it should send to your email. So if you know someone who registered but couldn't attend today, they will also get a recording as well. So thank you so much for taking time out of your day to spend with me to talk about winter weather. And y'all have a great rest of your weekend. And don't forget, we fall back over Sunday, 2 a.m. Don't forget to turn your clocks back so you're not early everywhere you go. Okay, y'all have a good weekend.